Hi, welcome to STAIR Tailored. My name is Jessica Mao and I'm with the University of Texas at Austin. This is the third video of a four-part series on how to multiply linear expressions. And in this video, we're going to use algebra blocks to multiply both positive and negative terms. Before we get started, I want to quickly review the idea of multiple representations. In Strickland's article, she talks about the use of CRAI, which stands for Concrete Representational Abstract Integrated. Here you see Concrete Pictorial Abstract. It means the same thing as CRA. The I, or integrated, means that there is no specific order or hierarchy in which you have to use the representations. So what that means is students don't have to always start with manipulatives and then pictorial and then abstract. They can use whichever representation they're comfortable or confident in using and they're good at. So essentially we want students, especially students with mathematics difficulty or disabilities, to be comfortable using manipulatives, using representation or pictorial representation to help them understand the abstract, which are the numerals and the symbols, to solve mathematics problems and to understand them. So now let's take a look at the top camera to use the algebra blocks to solve multiple linear expressions with positive and negative terms. Before we multiply expressions, it's good to review the rules of multiplying integers first with your students. Remind students that when you multiply two integers with the same sign, the product is going to be a positive product, but when you multiply two integers with different signs, the product is going to be negative. In this video, I'm using a different set of algebra tiles in which they're two-sided, in which the color side, the blue and the beige and the green represents positive value, but when you flip them over, when they're red, they represent negative value. So now let's go ahead and multiply these expressions. I've written here the expression x plus 3 times x plus negative 1, but it might also make sense to write it as x plus 3 times x minus 1. Both are correct, and again, this would be a great opportunity for you to talk to students about why these mean the same things. So you'll notice in our problem here that in our corner piece, we're going to have two terms. We have x plus 3 and x minus 1, or a negative 1. And we're going to use the same procedure to multiply these manipulatives. So what is x times x? That is x squared. Then we can either multiply x times negative 1 or x times 3. The order does not matter. Right now I'm just going to go with x times 3, in which I will have 3x. Next, I'm going to multiply x with negative 1, and the product is negative x. Finally, 3 times negative 1 is negative 3. Once we are done multiplying using the manipulatives, we're going to translate the product inside the corner piece into the abstract representation. First, we have an x squared piece, so I'm going to write x squared right here. Next, we have 3 positive x and 1 negative x. This is where we prompt students to practice using zero pairs. One of the positive x and then one of the negative x cancels each other out. So we are left with positive 2x. Finally, we have negative 3, so we write minus 3. After modeling for the students how to use algebra blocks or algebra tiles to multiply linear expression, allow a couple more practice opportunities for students to build a concept of this multiplicative relation between expressions and their factors, as well as the procedural fluency to arrive at the answer and the abstract representation. Thank you for watching this STAIR Tailored. Make sure to watch the last video of this four-part series on using graphic organizers to solve contextualized problems.